Hey guys, welcome to our channel. I'm Sagara, a senior at KL University studying computer science and engineering. Today we are going to learn about quicksort algorithm. In this video, we'll be seeing introduction of quicksort, steps of this algorithm, then we'll see an example to understand it better. We will also look at a piece of code following this algorithm, and at last we'll see the time complexity of it. Let us just dive into the topic. What is quicksort? Quicksort is based on the idea of divide and conquer. What is divide and conquer? Assume we are given an array of certain length and you are asked to sort it. What you will do is you will divide that one array into different parts and you will sort those each part till the element is 1. So that is what it is called divide and conquer. But for this particular quicksort, what we are doing is we are taking a pivot element. So that pivot element, what it will do is the numbers in the array which are greater than the pivot will be placed on the right side, and the numbers which are lesser than the pivot will be placed on the left side of the pivot element. That is what is the basic idea of quicksort. Let us just uh, make it more elaborate through understanding the steps of this quicksort. Let us see the steps of quicksort algorithm. So these are the steps of quicksort algorithm. What you will do is you will take a pivot element. This pivot element does not mean that it will be the starting element or the ending element or the middle element. It is your wish. You can take any number from the array as a pivot element. But what you have to do is you have to take that pivot element and compare it with the rest of the array elements. If the array number is greater than the pivot element, you'll place to the right side, and if it is lesser, then you'll place it to the left side. And now it doesn't mean that on the left side it will be compulsorily sorted. So what you'll do is apply quick sort again on the left part and the right part, and you will be dividing that particular parts till the element is 1 and the whole array is sorted. Those are the four basic steps. So what you're basically doing is you're calling the quicksort function again in that quicksort method only. So it is a recursive function also. So let us look at an example to understand this better. Now let us take an array of numbers 10, 16, 8, 12, 15, 6, 3, 9 and 5. This array has the length of 9. According to the first step, what we have to do is we have to select a pivot element. As I said, pivot element can be the first number, the last number, the middle number, anywhere. So for your better understanding, I'll be taking the first element 10 as the pivot element. After this, we need to go through the steps and understand this algorithm. So I will make you go through it. Now what we have to do is we have to consider a lower value and a higher value. Let us take infinity as the maximum value because it is a written algorithm right now and we are taking an example. So I'm considering infinity as the maximum value just to compare. And then the next step is we have to take I and j values. I value being equal to the lower value, j value being the equal to higher value initially. Now we have to move I and j in that way that I should be incremented till the number is greater than the pivot element. If the number is less than the pivot element, then you keep incrementing it. If it is greater than the pivot element, you stop there. And as of j, you need to decrement it, reverse of I. You need to decrement j until the element is lesser than the pivot element. J is the reverse of I. So in this example, let us see the next element, which is 16. We can see that 16 is already greater than 10. So we'll just increment and stop here. as of j. Next element is 5. 5 is lesser than 10. So we'll stop j here. The next part, what we are doing is I and j are stopped here. So we'll swap these. We'll swap 16 and 15. So the element 5 lesser value will be going to the left part, 16 which is bigger value will be coming to the right part, as we have seen earlier in the algorithm. So as you can see, 16 and 5 are swapped. Let us continue with the algorithm. Let us take the next one. 8 is surely less than 10. So which will not do. So we are keeping incrementing I till we get the greater value than the pivot value. So 12. 12 is greater than 10. So I will be coming here and stop. Then next, let us go to J. Next is 9. 9 is lesser than 10. So J will stop here. What we'll do is we'll swap 9 and 12 here. As you can see, we swapped 9 and 12. Next, what we'll be doing is we'll just increment it. 15, it is greater than 10. We'll stop here. Next, we'll go to 3. 3 is less than 10, which then again we have to swap these 3. As you can see, we swapped these. Next, I will be incrementing 6. 6 is less than 10? No. So we'll increment I again. I will be here. So 15 is greater than 10. I will stop here. Next, J. J will go to this 6. 6 is less than 10. So J will stop here. At last, what is happening is J is I is surpassing J. So if I is surpassing J, then the algorithm will stop. So as you can see, I has surpassed J, so algorithm is stopped, and we have swapped the values here. We have swapped 6 and 10. When I surpasses j, you need to swap the pivot value with the j value. So we have swapped 6 and 10 here. And it is the end of the example actually. And after this, you can see what we have got. We have got a pivot element, and numbers which are lesser are on the left side. The numbers which are greater are on the right side, as we have assumed. Now what we have to do is we have to apply quick sort to the list to this left part, as this is not sorted, and we have also have to apply quick sort to the right side part till we get the sorted array. That is basically the example. Okay, now let us look into the code for this algorithm. Firstly, we'll take a method called partition, and the arguments will be the lower and the higher value. The next step is to take the pivot value. In this case, in our example, we have taken the a of L, which is the first element, as pivot. So I have taken accordingly. In our case, it is 10. Next step is to allot the I and j values. So lower value will be allotted as I and higher value will be allotted as j. Then now we'll start moving I and j. How we'll do that is we'll take a while loop, and then I should always be less than j. Until I is less than j, we'll perform these steps. And if it surpasses, which means I becomes greater than j at the last step, then we'll come out of this while loop. So in this while loop, what we'll do is we'll increment I. We'll keep incrementing I until we'll keep incrementing I while a of I, the element I, is less than or equal to pivot value. The time when the pivot value becomes, when the I value becomes greater than the pivot value, we will stop at that point. And we'll perform the reverse condition for j. When j value is less than the pivot value, we'll stop. And then after that, what we'll do is we'll perform swap, as we have seen in the example. So in the condition when I is less than j, we'll swap I and j. As we have seen in the example, we are performing the swapping function. So here it comes. So now what happens? After the end swap, what happens is I becomes greater than j. I surpasses j, as we have seen in the example previously. Then the condition will come out of this loop. When it comes out of this loop, we'll perform swap between the pivot element. Here we have taken the first element a of L, so I have mentioned it here. So pivot element and the element j, which was 10 and 6 in our case in the example, we are performing swap here. And at last, we'll return the j value. So after this whole partition method, we'll perform the quick sort method, taking again the arguments lower and higher values. If we'll take the condition if lower value is less than the higher value, J will perform the partition method, which we have seen before. After the partition occurs, it is divided into two parts. Then we'll go to the quick sort value. Again, quick sort function we are performing. I have told you that this is a recursive function. That is what we are saying. So it is a recursive function. So we'll perform the quick sort on the left side, which is the first element will be L, the last element will be J. And again, we are performing the quick sort on the next half, which is the right part, which is in which the first element is J plus 1 and the last one becomes the higher value. And it will continue till the lower value is less than H, which means till the array is completely sorted. So that is the code for this algorithm. Now let us understand the time complexity of quicksort algorithm. Basically, for other sorting techniques like merge sort, it will have only one time complexity. But considering quicksort, we'll have two, which is best case and worst case. I will explain both of them to you. So let's see. For the best case, let us take an example and consider an array of 1 to 15 elements. It is always better and best to take the middle element as the pivot element. So that's what I have done here. So after dividing, so it is divide and conquer rule, right? So after dividing this 1 to 15 elements, let us take the middle element as 8. We are dividing it into two parts, 1 to 7, 9 to 15. Again, we'll apply the same thing here. We'll divide it into the middle, 4 as the middle number, into two parts. Then again 2 as the middle number, then two parts. We'll apply that thing only to all the numbers, all the parts which we are getting. So at last there will be only one element left. So this is the best case. How? We'll see. In each step, n elements are taken, right? So n here. But we are dividing this n element into two parts. So n by 2. Again n by 2 here. Again n by 2 here. So we are dividing that n into by 2 by 2 by 2 as we can see here. So what we can do to this continuous thing is we can consider n by 2 to the power k, which is the value which equals to 1 time complexity. Then what we'll do is n is equal to 2 power k. We'll evaluate this process and we'll get k is equal to log n. Now, how many steps were there? There were n steps. So, n log n will be the time complexity in the best case for quicksort. Now, let us look at the worst case. When does worst case happen? Worst case happens when you are given a sorted array and you are again asked to sort it. So what happens is that element will compare itself how many times to the greater element, right? One will be comparing, two will be comparing, unnecessarily all the smaller elements will be comparing to the bigger ones, and the process will continue for long. So it is the worst case. So what is the sum of n elements? It is into n plus 1 by 2, which is n square. So this is the worst case of quicksort algorithm. So that is basically the time complexity. And here we are at the end of our presentation. I hope you understood this quicksort algorithm in a good way. And thank you. I'll see you in the next one.